and 2 output ports. At a given time slot, 2 input ports and 2 output ports. At a given time slot, a packet arrives at each input port with probability 0.5. So which means probability that packet arrives in input port J equals 0.5 or 1/2. J equals 1, 2. You tell me what is the probability that no packet arrives in input port J. What is this probability? Packet arrives in input port J with probability 1/2. Therefore, no packet is going to be probability that no packet arrives in input port J is going to be 1 minus 1/2 equals 1. So that is the key here. That is what we are going to utilize. Now, once a packet arrives in input port 1 or input port 2 with probability 1/2, that packet has the equal probability to reach output port 1 or output port 2. So 50% probability, 50% chance that that packet would be destined for output port 1 and 50% chance that that packet will be destined to output port 2. Which means that once a packet arrives, that packet can go to output port 1 with probability 1/4. Which means packet arrives in one of the ports with probability 1/2, and packet, once it reaches, packet can go to one of these ports with probability 1/2. Okay? Now, this and probability that packet arrives in input port 1 and probability that packet goes to output port 2, and it is going to be 1/2 times 1/2. It's going to be 1. And that's what I wrote here. Packet to output port 1 with probability 1/4 and packet to output port 2 with probability 1/4. You guys understood? So that's the philosophy behind it. Okay. Now let X and Y be the number of packets destined for output ports 1 and output port 2. So X represents random variable X. So this is a random variable. Random variable X random variable X, random variable Y represents the number of packets arrived or destined for output port number 1, and random variable Y represents the number of packets arrived in output port number 2 or destined for output port number 2. So I have written it right here. So the first question is find the joint range of random variable X and random variable Y. So S sub X comma Y equals 1. And the second question is find the joint PMF of random variable X and Y. Third question, show the joint PMF in tabular format and show the joint PMF in 3D plot. So in this figure, I tried to put as much information as possible. So I said here, for each input port, no packet probability is 1/2. Packet to output port 1 with probability 1/4, packet to output port 2 with probability 1/4. And when no packet arrives, it contributes to random variable x equals 0. So random variable x equals 0, random variable y equals 0. So when no packets arrive, which means that it's x equals 0, y equals 0. When one packet arrived in output port number 1, it contributes the random variable x equals 1, here x equals 1, here y equals 0. And this is going to be x equals 0, and this is going to be y equals 1. So packet to output port 2 contributes x equals 0, y equals 1. And packet to output port 1 contributes x equals 1, y equals 0. In this 2D graph, what I showed, try to understand here, that way it's going to be easier for you. So this 2D plot, it shows the grid plots are generated. So this 0, 0, this 0, 0 means it's x equals 0, y equals 0, which means that the number of packets arrived in output port number 1 is 0, number of packets arrived in output port number 2 is 0. This coordinate means number of packets arrived in output port number 1 is 1, number of packets arrived in output port number 2 is 0. But 2, 0, what does that mean? Okay, guys, here is another confusing point. So how come it can be 2, 0? See, a packet can arrive in input port number 1 and in input port number 2. So therefore 2 packets can arrive. So each of these packets can go to either output port number 1 or output number 2. Even the packet can arrive in input port number 1, it can go to output port number 2. Right? Packet can arrive in input port number 1, but it can go to output port number 2. Packet can arrive in input port number 2, but it can go to output port number 1. So therefore, each of these output ports can have actually 2 packets. But total number of packets, that is another point here. The total, I'm going to use red color because this is the constant here. So the event that can never happen is the total number of packets x plus 1 has to be less than or equals to. It cannot be more than 2. So that's why this cross denotes these are impossible outcomes. Impossible outcome. So 1, 2, which means that x plus y equals 3, that cannot happen. 2, 2, which means that x plus y equals 4, this cannot happen. 2, 1, which means that x plus y equals 3, which cannot happen because x plus y has to be greater than or equal to 4. So at most 2 packets. So that's the illustration. Now let's see the joint range. So I actually gave you the joint range right here. So joint range, again, try to understand the outcomes, elementary outcomes, guys. So this outcome I denoted with zeta. Outcome NN, it means that no packet arrived in input port 1 and no packet arrived in input port number 2. And this comma denotes AND. So no packet arrives in input number 1 with probability half, and no packet arrives in input port number 2 with probability half. So half times half gives you the probability 1/4. Okay. Now what is this, guys? No packet arrives in input port number 1 with probability 1/2. Now packet arrived in input port number 2 and it actually went to destined for output port number 1. So packet arrived in input port number 2 with probability 1/2, and then that packet went to output port number 1 with probability 1/4. So 1/4 times 1/2 gives you 1/8. Did you understand? Okay. Yeah, it's a bit confusing. I'm just going to write it down. So let's talk about this outcome. Okay. So one outcome is N A1. This is one outcome. What it means, we have input port number I1, let's say this is I2. So this is I1, input port 1, this is input port number 2. Okay. No packet arrived in input port number 1. This N means no packet arrived in input port number 1. This probability is, I'm just going to write it like that for simplicity. This probability is 1/2. And this is AND. This comma is AND. Now, packet arrived in input port number 2. Packet arrived in input port number 2, that packet A1, this 1 represents that packet went to, this packet went to, this packet went to output port number 1. And this A2, this packet went to output port number 2. So packet in the second argument represents that this packet arrived in input port number 2, but it went to output port number 1. This comma represents AND. So now let's work on this one. Okay, what is probability that no packet arrived in input port number 1 is 1/2. Probability that no packet arrived in input port number 2 is 1/2. But therefore probability that packet arrived in input port number 2 is 1/2. So probability that packet arrived in input port number 2 is 1/2. But this packet went to output port number 1 with probability another half. So that half, input port probability half, and this half will give you 1/4. So this gives you 1/4. And this 1/4 with this N, because this is N, will give you 1/2 times 1/4 gives you 1. Did you understand now? Clear? Yeah. So yeah, I know that it's a bit confusing, but as you go, it's going to be more clear. So here I actually gave you all the outcomes. No packet arrived in input port number 1. No packet arrived in input port number 1. So this probability is 1. No packet arrived in input port number 1. One packet arrived in input port number 2, that is destined for output port number 1. So this A1 represents output port number 1. It went to output port number 1. So packet arrived in input port number 2, but it went to output port number 1 with probability 1. With probability 1/4 in total. So here, so packet to output port number with probability 1/4. So that 1/4 and this 1/2 will give you 1. So same thing, no packet arrived in input port number 1 with probability 1/2. So this is 1/2. Packet arrived in input port number 2, but that packet went to output port number 2. So this is A2 means out, it went to output port number 2. So this gives you probability 1/4. So 1/4 times 1/2 gives you 1. Now let's move on to different scenario. So here, move on to this scenario. Okay, A1, what does that mean? A1, it is the first argument of the outcome. So A1 means, A1 in the first argument means that packet arrived in input port number 1 with probability 1/2. And that packet went to output port number 1 with probability 1/4. So this A1 gives probability 1/4 in total. So packet arrived in input port number 1 with probability 1/2. Packet went to output port number 1 with probability 1/2. So 1/2 times 1/2 gives you 1/4. Packet arrived in input port number 1 with actually input port number 2. Packet arrived in input port number 2 with probability 1/2. Packet went to output port number 1 because both of them A1. So this gives you probability 1/4 in total. So 1/4 times 1/4, total probability is, joint probability is 160. Now the joint range, because both of these packets went to output port number 1. So that's why in x equals, this is x equals 1, x equals 2, so this is y equals 0. So no packet went to output port number 2. So because you have A1, it went to, both went to output port number 1. So that's why x equals 2, y equals 0. Same thing for A2, which means that packet arrived in input port 1, went to output port number 2. Packet arrived in input port number 2, went to output port number 2. So both of these packets went to output port number 2. So that's why here probability, just like what we did for this outcome, here probability is 116, joint probability is 116, but the element in the joint range is x equals 0, y equals 2. So the first solution, the solution of the first point here, number 1, solution of the first point is joint range. I'm just going to write it down here, joint range. S sub x comma y is going to be x could be 0, y could be 0, comma, x could be 1, y could be 0, x could be 2, y could be 0, x could be 0, y could be 1, x could be 0, y could be 2, x could be 1, y could be 1. So 1, 2, 3, 4, 5, 6. So total 6 elements in the joint range. If I ask you what is the sample space, what is the sample space? Sample space S is basically set of all outcomes. Set of all outcomes. This sample space is basically N, which means no packet arrived in input port number 1, no packet arrived in input port number 1. So no packet arrived in input port number 1. One packet can go to packet arrived in input port number 2 can go to output port number 1. Okay. So no packet can arrive in input port number 1. And another packet can arrive in input port number 2, but that can go to output port number 2. Okay. So now let's go the other way. Now packet can arrive in input port number 1, and in input port number 2, no packet arrives. So that is another outcome. Packet can arrive in input port number 1, that can go to output port number 2. So, and in the second input port, no packet can arrive. So this is another outcome. So 1, 2, 3, 4, 5. Now, one packet can arrive in input port number 1, another packet can arrive in input port number 2, but both of them can go to output port number 1. One packet can arrive in input port number 1, and another packet can arrive in input port number 2. So this packet can go to output port number 1, this packet can go to output port number 2. Same thing, A2, A1, and similarly A2, A2. That's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 outcomes that you can see. So if you go here, you see N, A1, N, A2, A1, N, A1, 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 A2, A2, N, A2, A1, A2, A2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 outcomes. You can see this. So total 9 outcomes. And for each of these outcomes, I computed this corresponding probabilities. Okay. So now I am going to apply the formula. Yeah, make sure you guys this, guys. It's a confusing example. I also agree. Okay. Make sure you pay attention. That's why I drew all the figures that I could think of. I took this example from the author's book, but these figures I drew just for you to. These are not in the book, so just so that you understand. So now let's go to the definition of computing the probability. Okay, so look guys, how I make use of this formula. So now I know the PMF. If I know the PMF of xj, yj, yk, so you have two values. Now you make double summation. For each point in the event B, you actually make double summation to get the total probability of the event B. So now what you see, you have this joint range, the element, you have this element in joint range, and you have this element in joint range. you have two different outcomes. Do you see, guys, here? N A1, here you have A1N. So you have two different outcomes, but these two different outcomes map to a single point on real line. So it's 1, 0, this is also 1, 0. So, but we got the probability for these two different elementary outcomes, 1, 8, here 1, 8. And that's why I drew these arrows to actually add them up. So this probability PMF of random variable x, comma y taking value x equals 1, y equals 0 is going to be 1, 4. Here the PMF of random variable x, comma y taking value 0, 0, it's 1, 4, we already know. So that's how I computed all the PMFs. Now guys, can you add them up? So these are joint PMFs. So we have the entire sample space. We have the entire sample space, and we actually map to the points in two-dimensional space. Now we can say these are joint PMFs if and only if the add summation of all these joint PMF values is 1. Okay? So you can see that 1/4 plus 1/4. Actually, let's start with 1/16. 1/16 plus 1/16 is going to be 1/8. 1/8 plus 1/8 is going to be 1/4. 1/4 plus 1/4 plus 1/4 plus 1/4. So if you add them up, you see that they are 1. So which means that we actually computed the joint PMF correctly. We defined the random experiment properly. We defined the outcomes properly. We defined the joint range properly. So therefore, we are able to prove that summation of all the joint PMF values is 1. All right. So this is so find the joint PMF of random variable x, comma y. So we found the joint PMF. So joint PMF values, we found the joint PMF values. So in short, you can just write it down as such. PMF of x, comma y, taking value 0, 0 is going to be 1, 4. PMF of random variable x, comma y, taking value 0, comma 1 is going to be 1, 8. PMF of random variable x, comma y, taking value 0, comma 2 is going to be 1/16. PMF of random variable x, comma y, taking value 1, comma 0 is going to be 1, 8. PMF of random variable x, comma y, taking value 1, comma 1 is going to be, what was 1, comma 1? 1/16.
No, 1, comma 1 is 1, 8.
Yeah, 1, comma 1 is 1, 8. Oh, 0, comma 1 is 1, 4. That's 0, comma 1 is 1, 4. 0, comma 2 is 1, 8. 1/16. So this is 1, 4. 0, comma 2 is 1/16. And 1, comma 0 is also 1, 4. 1, comma 1 is 1, 8. What else?
We're missing a 2, comma 0.
Yes, that 2, comma 0 is going to be 1/16 as well. Can we add them up, please?
Yeah, it's 1.
Yeah, 1, 8. So in short, you can write it like that. So this is joint PMF. When I ask you to write joint PMF, this is what you write. Okay, next. Next, show the PMF in tabular format. Okay, so this PMF, you can write it also, because you see repeated values, what you can see, you can actually write or you can write it as such. PMF of random variable x comma y taking value x y equals, you can write it as such. 1/4 if x comma y or 4 x comma y equals 0 0 1 0 0 1, and it's 1/8 for x comma y equals 1 comma 1, and it is 1/16 for x comma y equals 2 comma 0 0 comma 2, and it is 0 otherwise. So in tabular format, joint PMF in tabular format, what you do, so here you have x, you have y. So this is x, you have y, because you are placing the values. This is 0, 0, 0. This is 0, 1, 2. So in tabular format, you write, this is your 1/4. Zero, 1, 4. So this is 1/4. This is 1/4. This is 1/16. This is 1/4. This is 1/16, and this is 1/8. And the other values you can write, those are zeros. Yeah, this is in tabular form. Okay. In three-dimensional space, this is in tabular format. In three-dimensional space, in 3D space, in 3D, the joint PMF, I don't know. So I can only draw two-dimensional, but 3D, the way you could do is, let's say this is your x, this is x, and this is your y, and then you So I'm going to use solid line. So this is your x here, y equals 0, x equals 0. So this is x equals 1, this is x equals 2, this is y equals 1, this is y equals 2. Okay? Now you can put dots right here. To use red dots. Dots right here, dots right here, dots right here. One dot right here, one dot right here, one dot right here, one dot right here. So how many dots we have? 1, 4, 3, 4, 5.
Why is there a dot at 1, 2?
Oh no, here. So this should be only. So there is no dot right here. Okay. So now at 0, 0, I'm going to use very thick. Okay, at 0, 0, you have 1/4. So at 0, 0, you have 1/4. At 0, 1, you have 1/4, same height. 0, 1, you have 1/4, same height. And then you have 2, 0, you have 1/16. 0, 2, you have 1/16. And then here you have 1/8. So I'm just going to label them. So this is 1/4. This is 1/4. This is 1/4. This is 1/4. This is 1/8. This is 1/16. 1/16. You see that? So that is the answer. Joint PMF visually shown in 3 dimensions. And then field dots. Joint PMF with field dots is basically the joint PMF. Yeah, joint PMF in 3D plot graphically. I showed tabular format graphically. That's all. So there is another way to show, it's called field dots. So which I actually showed right here. So this is field dots. Okay. So I'm going to conclude my lecture here. So make sure you know this example very well, because down the line I will be using this experiment as the base, and we will solve all of the quantities. Okay. So this example is going to serve as the base for many examples to come. Okay. So I'm going to stop right here, and I'll see you on Friday.